So in question 12, we've got a question. On her way to the theatre, Sheila passes through 3 sets of lights. The probability that each set of lights is green is 1/3. We want to calculate the probability that none of the lights is green and the probability that 2 sets of the lights are green and the other is not green. So I've already made the tree to represent the 3 sets of lights as S1, S2, S3. The green represents the green light, so we can write that in. So this is green, 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 like that. And the yellow just represents not green. So I guess we can write N for that, N for not green. Okay, so from the question, it says the chance that the light is green is 1/3. So all of these lights have the same probability that are green. So your probability of green is 1/3, which implies that the probability of not green is 2/3, because the light is either going to be green or not green. So the sum of those probabilities should be equal to 1. That's why I know that this probability is 2/3, because it has to be added to 1/3 to give 1. So we can write these numbers onto our tree. So everywhere where you see green, you write 1/3, every branch. So you put in 1/3 everywhere where you see that. Like that. And not green is 2/3. So everywhere where you see not green. And we're missing not green there, aren't we? So let's put that in. So that will be 2/3, 2/3, and 2/3 down there, and 2/3 on that one. So what are your possible outcomes? You could get 3 greens, green, green, not green, green, not green, 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 not green, not green, not green, 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 not green, green, not green, not green, not green, green, and not green, not green, not green. That's the last one. So we can calculate our probabilities for each of these. Let's move up a little. So let's put them in. So remember, we multiply the probabilities along the tree here for our multiplication law. So this would be 1 on 27. This would be 1 times 1 times 2, 2 on 27. 1 times 2 times 1, that would be 2 on 27. 1 times 2 times 2, 2 2s are 4, 4 on 27. 2 1s are 1, 1, 2 1s are 2 on 27. 2 1 2, 2 2s are 4 on 27. And the last one, 2 2 1, that's 4 on 27. And 2 2 2 is 8 on 27. So you should add those numbers up to check you get 27 out of 27. So what do we have? 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 24, 25, 26, 27. So this looks correct because I've added the fraction up. Remember, when you go down the tree, you add probabilities. And at the final step, we notice that they all add up to 100%. So it looks like the tree is correct at this point. So then we can try to answer our questions. What is the probability that none of the lights are green? Well, that would be n, wouldn't it? So this is going to be probability of none, 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 which is going to be 8 out of 27. So that's the chance that none of the lights are green. And we leave it like that, no need to simplify. what is the probability that two sets of lights are green and the other is not green? So now we're looking for two sets of lights being green. This one, two green, that's this one. Two green is this one. And that looks like it. So that's going to give us 6 out of 27. So two sets of green could be written as probability of green, green, not green. Green, not green, green. Not green, green, green. So when you add them up, you got 2 on 27 plus 2 on 27 plus 2 on 27. That's going to give you 6 on 27, which is going to give you 2 on 9 as your final probability for question B.